In this video, we'll go over the definitions and purpose of business intelligence, artificial intelligence, and analytics. Specifically, our learning objectives are to understand how changes in the business environment impacts organizations and how computerized support for managerial decision-making can help organizations. We'll also learn about different types of analytics, an overview of business intelligence methodology, basic concepts related to artificial intelligence, and we'll understand the analytics ecosystem and identify various key players and career opportunities. Decision making is one of the most important activities in an organization. The kinds of decisions that we make in an organization can be categorized into four types: big bet, high risk decisions, cross-cutting decisions, which are repetitive but high risk that require group work, ad hoc decisions that arise episodically, and delegated decisions to individuals or small groups. Managers usually make decisions using a four-step process, which involves defining the problem, constructing a model, identifying and evaluating possible solutions, and then finally to compare, choose, and recommend a solution to the problem. A more detailed process would involve understanding first the decision that needs to be made, collecting all the information related to that decision problem, identifying alternatives, evaluating the pros and cons of each of those alternatives, then selecting the best alternative, making the decision, and then evaluating the impact of that decision. However, there are several factors that complicate the decision-making process. For example, you have technology availability, internet, which is a great source of information and has made available large amounts of information, as well as because of the continued developments in technology, you have lots of alternatives to choose from as well. So evaluating all of this can be cumbersome. Then there are also political and economic factors. For example, new tariffs or environmental factors, or for example, we have certain emergence of a pandemic like the COVID pandemic that add a lot of uncertainty and make it hard to predict the outcomes. That adds to the need, and when you add to that the need to make rapid decisions in changing market conditions, all of these factors make the process of decision making a very complex task. Therefore, we need new tools and techniques to help support decision making. These information technology tools and techniques can support decision making in a number of different ways: by better communication, better data management, better analytics and models, sharing of knowledge, and improved accessibility. For example, let's say you're managing your personal finances. And in that process, if the only way to know the balance in your bank account was based on end of the month bank statement, it can create some problems. However, you can make better financial and spending decisions if that balance information was better communicated and you have better availability of up-to-date data through improved data management. What would help even more is if there was a model to project the balance based on known or expected expenses. That is analytics support. Further, when you have tips from financial planners or others on how to reduce expenses or better manage spending and debt, that would help even more. And that would be called knowledge management. So what is in a decision-making process? Herb Simon, a Nobel laureate, proposed a three-step process to decision-making. It involves intelligence, design, and choice. And following this three-step process, we can also think of implementation of that decision and monitoring the results of that decision. The decision-making process starts with intelligence, which involves identifying the organization's objectives, searching and scanning procedures, collecting data, identifying the problem, ownership of the problem and creating a problem statement. Once you have a problem statement, next comes the design phase. And in this phase, you formulate a model for the problem and you set up a criteria for choice. So once you have identified alternatives, what are the criteria that you're going to use to evaluate those alternatives? And then you search for alternatives and predict and measure the outcomes of those alternatives. Finally, you have the choice phase, which involves solution to the model, a sensitivity analysis. What if your assumptions are wrong or things go slightly different? And then selection of the best model or the best alternative and a plan for implementation. And this is an iterative process as well between intelligence, design, and choice. So we know that there are different types of decisions to be made. Some are routine, some are ad hoc decision problems, and then you have decision problems with varying levels of complexity. So how do we support these different kinds of decision problems? Corey and Scott Martin created a framework to map decision support systems to different types of decision problems. The framework looks at where the decisions are made, whether they are strategic, and they look at how structured those decision problems are. For example, some problems such as inventory reordering, they're more structured problems as opposed to others such as what software to purchase or negotiating pay or recruiting. These are have less structure to them. So here's an early framework for decision support. The framework looks at the types of control and how structured the decision problem is. So the types of control can vary from operational control, management control to strategic planning, whereas structuredness could be very structured problems, semi-structured problems, and unstructured problems. A problem such as monitoring accounts receivable or monitoring accounts payable. These are very structured problem and then also very operational. They are problems or decision problems that you encounter while running operations. Whereas managing overall organization finances, monitoring the investment portfolio, deciding where to locate a warehouse, these are also structured problems, but are more at a strategic planning level, not necessarily day-to-day operations. Then on the other end of the structuredness, you have unstructured problems, such as buying software, approving loans, operating a help desk. These, again, are more operational, whereas at the strategic level, you have research and development or developing new technologies, planning social responsibility. These are strategic but unstructured planning. In order to support the different types of decision problems, a decision support system needs to have a certain set of key characteristics. A list of key characteristics are shown on this slide and include characteristics such as providing support for semi-structured or unstructured problems, supporting managers at all levels, supporting individuals and groups, uh, being able to support interdependent or sequential decisions, and being able to support the different phases of decision making, such as intelligence, design, choice, as well as implementation. And a DSS needs to be able to support a variety of decision processes and styles, be adaptable, flexible, be interactive, and easy to use, and so on. A decision support system has multiple key components. One of the most important components is the data management system. This is where the data that is needed for decision support is stored. And data can be internal, generated within the organization, or can be external, can come from other sources. Uh, the data management systems consists of the database, a database management system, a data dictionary that describes the data, that is present in this database, as well as a querying facility. Other components of a DSS are a model management system that consists a model base, which is a repository of different models, a management systems for the model base, a language, so you can develop new models, a directory of models, as well as support for execution of the models and integration and command processing. In addition to model management subsystem, you also have the user interface as well as a knowledge base subsystem. Decision support systems have evolved since the 1970s when decision support systems included systems such as routine reporting systems, AI expert systems, and over time, decision support systems have evolved with technology to now include systems such as robotics, artificial intelligence, and automated analytics. The term business intelligence was coined by the Gartner Group in 1990s. However, the concept has been around for much longer. It started off as management information systems and executive information systems in the 70s and 80s to the coining of the term business intelligence in 1990s. And nowadays, business intelligence includes data and text mining capabilities as well. The architecture of intelligence includes what is called as a data warehouse, which is a repository, large repository of historical data as a foundation of business intelligence. And in addition to that, you have business performance management and a user interface, which is typically called a dashboard. Databases in general in business are used for two different purposes. When they're used for supporting routine business operations, such as sales transactions, when you purchase a product at the store, you have databases to support that sales transaction, and that's called a transaction processing system. Whereas when it's used for decision support, such as identifying sales trends, when the store manager wants to find out, what products are popular and selling really well, then the databases that are used for that purpose are supporting analytics, and that's called analytics processing. The business intelligence technology and strategy in an organization needs to be in alignment with the business strategy of the organization. Here is a brief overview of how business intelligence has evolved over the years to include tools such as simple spreadsheets to dashboards, portals, and predictive analytics. Here's a high-level architecture of business intelligence. It starts off with different data sources. You gather data from multiple different sources, you clean it up, and then you store that in a data warehouse. Then you have, so this part of taking the data from different data sources and storing it in a data warehouse is primarily performed by the technical staff. Then you have business users who access the data warehouse and create reports using a user interface. This can be a browser-based interface or accessing a portal or a dashboard. And based off of these reports, then you have managers and executives who develop strategies for business. Digging deeper into this architecture, here's a more detailed data warehousing framework or data warehousing architecture. So the different data sources are typically the enterprise resource planning or data from enterprise software systems. You have legacy databases, point of sale transactions, and other external data. All of this data is then transformed using an ETL process, which stands for extraction, transformation, and loading, to clean the data and then transform it and then load it into what is called an enterprise data warehouse. So an enterprise data warehouse consists of cleaned and historical data uh, related to all the different business operations of a firm for which data is collected. Then, based off of this data warehouse, you create data marts for specific business areas or specific departments, which are then which then feed into business intelligence and business reporting systems uh, that create reports based off of that data. Another new term we see these days is analytics and data science. There's a lot of overlap between these different terms that are used, and different people use it to mean different things. Analytics is just another way of looking at decision support systems. The organization Informs proposes a taxonomy for analytics that consists of descriptive analytics, predictive analytics, and prescriptive analytics. Descriptive analytics relates to looking at what has happened or what is happening. And the type of tools you use for this is business reporting tools, dashboards, scorecards, and data warehouses. And typically, we use descriptive analytics for much well-defined business problems and opportunities. Then you have predictive analytics, which is about exploring what will happen and why it will happen, or predicting outcomes. So for this, the type of tools that you use are data mining, text mining, and forecasting. Um, Predictive analytics tools are used for accurate projections of future events and outcomes. Then you have prescriptive analytics, which is about what should be done, okay, given different scenarios and why you should do it. The type of tools you use for this type of analytics are optimization tools, simulation tools, decision modeling tools, or expert systems. And the outcomes for prescriptive analytics is finding the best possible business decisions and actions given different scenarios. Analytics is used in a lot of different fields. Um, For example, one field is sports analytics, where analytics can be applied for decision problems in sports business. It can be used both in the front office, figuring out, which player to recruit. For example, player to trade for in NBA or NFL, or which player to select in the draft, and also in the actual playing of the game um, for coaching purposes as well. You know, in a particular game, who would be the best starters uh, given the nature or given the skills of the opposing team, and so on. It's widely used in healthcare as well. There are several examples where analytics is being used in healthcare and medicine. For example, preventing falls in senior population, defining the right metrics for quality of healthcare, predictive models to identify disease conditions or highest risk, patients at the most highest risk. And it's used widely in retail industry. It's used for image analytics, searching images, identifying images, uh, and so on. Here is an example of analytics application in retail value chain. Analytics can be applied from vendor selection and identifying in supply chain management, optimizing inventory costs, can be used in the planning stage for shelf space organization, shelf and floor planning, at the buying stage, looking at trends analysis, what products to purchase, better forecasts of demand. It can be used all the way through to supporting the customers, building retention and satisfaction, better understanding needs of customers, and so on. Another term that you see that is quite popular now is artificial intelligence. So what is artificial intelligence? It's a technology that can learn to do things better over time. And artificial intelligence technology can also understand human language. It's a technology that can help answer questions as well. Some of the major benefits of AI are in helping reduce cost of performing work much faster and more consistently than humans, ultimately leading to increased productivity and profitability. The major technologies in the AI space are either knowledge-based technologies, such as recommendation systems, expert systems, and then you have biometric-related technologies, such as computer vision or speech recognition. The tools and platforms that are available for building AI systems are supported by many different companies. For example, Google, Meta, Microsoft, they all have built platforms and tools for building AI systems. AI has applications in many areas, including things such as self-driving cars, fraud detection, e-commerce. AI applications typically focus on one narrow domain, such as image, for example, image recognition or speech recognition. Um, so these are called narrow or weak AI. But however, over time, the goal is to build a general AI system that can do multiple things, such as humans can. AI systems can be categorized into um, three different flavors. One is assisted intelligence systems, which have narrow domains and scope. For example, monitoring systems that give us alerts. Autonomous systems that are in the realm of strong AI, but in narrow domains. For example, robo-advisors in finance or airplane autopilots. Then we have things that fall in between assisted and autonomous systems, and they are called augmented AI. Examples are stock trading systems or cybercrime detection systems. AI can have a substantial impact on society. For example, AI can be used in agriculture, using technologies such as machine vision that can help with harvesting and sorting food. AI is also being widely used in medicine for diagnosis, disease prediction, monitoring and alerts, and there are several applications in a number of areas such as transportation, utilities, education, and social services as well. The difference between analytics and AI is that analytics focuses on historical data to describe situations and predict the future based on that past data and patterns. Whereas AI, the major objective is to mimic how people think, how people learn and reason, and to make decisions to solve problems. AI also more deals more with cognitive computing. However, in reality, the difference between AI and analytics is not so clear because in a lot of analytics applications, we use AI algorithms for prediction and prescribing solutions. We are also seeing a convergence of AI. So what we're seeing is a convergence of AI and analytics. This conversion is being helped by a number of different factors, such as availability of big data, which is necessary to develop high quality AI applications, and the development and adoption of Internet of Things, IoT systems, which creates this big data, and many new sources of data that were not available earlier as well, which are now available with new tools such as blockchain. And um, so such conversions is also being supported by development of tools and platforms by companies such as Google, Meta, Microsoft, Amazon, and others. So here's a broad overview of the analytics ecosystem. At the outer level, you have technology providers. They provide technology for analytics applications. Then you have analytics accelerators in the intermediate layer that work with the providers and users to make adoption and acceleration possible. Finally, at the core, you have users that drive the analytics. So we'll be using the analytics, data science, and artificial intelligence book for this course. And the book is divided into number of different modules. First is Introduction to Analytics and AI. Then you have Predictive Analytics, Prescriptive Analytics, Robotics, Social Networks, AI, and IoT, and Caveats of Analytics and AI. We'll be focusing on, in this course, in many of these areas. One specific area that we won't be looking at is prescriptive analytics, specifically Chapter 8, Optimization and Simulation. You will go over that in another course in decision science, but we will focus on the many topics in the other chapters.